Hello, my students, and welcome to this tutorial. In this episode, we are going to discuss together the tree diagram. And before we start, I want to show you what is the meaning of a tree diagram. The tree diagram, it's all about outcomes. So if we are talking about a head and tail in the experiment of tossing a coin once, what is the probability of getting a head? It's 1/2. And what is the probability of getting a tail? It's 1/2. When it comes to outcomes only, so we have head and tail. Okay, this for the first toss, we can get head and tail. Now let's look at this example. The arrow on the spinner is spun twice. Okay, we have win and lose, and the number of wins recorded. Draw a tree diagram showing the possible outcomes. So let's have a look at the example again. The spinner is spun twice, 2 times. So for the first time, the first spin, we might get win or lose. So we write W or L. Or not winning, we can write W dash, winning or not winning. The second time, after getting winning, we might get Abdullah. Win and lose. That's right. We write it as W and W dash. And for the second time, if the spinner landed on losing, not winning. So the second time you might get win W, or losing, we call it W dash. This for the first example. Let's go to the next one. How can we move? Okay. Number 2. A box contains 1 red sweet, 4 blue sweets, and 3 green sweets. Pay attention, everyone. 2 sweets are taken from the box. 2 sweets are taken from the box, one after the other without replacement. Pay attention, without replacement. And we have 2 sweets are taken from the box, one after the another without replacement. Okay, draw a tree diagram to show the possible outcomes. Mustafa, how can we draw the tree diagram for the first one? Because we are going to take 2 sweets. We have 1 red, and we have 4 blue and 3 green, and pay attention, without replacement. So for the first sweet, we might take what? Red, or we might take green, blue, or we might take green. Okay. Once you have taken the red, so you are left with what? 2 choices only. You might take blue or green. Okay. And if you took the blue, so you are left with how many choices? We have 3 choices, because the red sweet exists. So we might take red or blue or green. We have 3 choices. And once you have taken the green, let's ask Abdurrahman. Okay. Green, once you have taken the green, if you took the green, okay, you are left with red, that's right, blue, and green. Why did you say green? Because we have more than one green. Let's go to the next one. A die is thrown at most 3 times. 3 times. If a 6 is scored, the game stops. If a 6 is scored, the game stops. Draw a tree diagram to show the possible outcomes. So, Mustafa, tell us for the first roll, if we roll the dice at the first, so we might get what? Okay, we have 6 choices. 1, okay, 2, 3, 4, 5, 6 choices. We have 6 choices, okay? The 6 choices are 1, 1, 2, 3, 4, 5, 6. Okay, Abdullah. When if you have got 6, the game stops. So what if you are going to get 1? So for the second, because we are going to throw the roll the dice how many times? Let's read it again. How many times? 3 times. Okay, a die is thrown at most 3 times. A 6, if a 6 is scored, the game stops. So draw a tree diagram. So for the first one again, you might get 1, 2, 3, 4, 5, 6. This is the first row. The second one, if you have got 1, then you are left with, or we can do the experiment again and roll the dice again. And if you roll the dice again, you might get what? 1, 2, 3, 4, 5, 6. Okay, when you got 6, the game stopped, because if you scored the 6, the game stops. What about this 6 here? Because we have got 6, so the game stops. We don't have any, pay attention please. We don't have any steps to do again, because the game stopped. We have got 6. If you got 2, we might get what? 1, 2, 3, 4, 5, 6. And the game, if you got 6, the game stops. But let's look at 1. If you got 1 and after that you have got 1, then we will do it again. So you'll get 1, 2, 3, 4, 5, 6. So it's horrendous to draw the tree diagram using this way, but I'll tell you a trick to draw the tree diagram. We might get 6 or not get 6 for the first time, okay? If you got 6, so the game stops. The game will stop. And if you didn't got 6, we call it 6 complement, any number except 6. So we will do it again. After doing it again, we will get what? We have 2 ways. You might get 6 again, okay? Or not getting a 6. We call it 6 days. So we have 6 or this not a 6. And for the, if you got 6, so the game will stop. Okay. And if you didn't get 6, we will do it again. We have, for the third time, we have what? We have 6. And the game, in this case, stops. And if we didn't get 6, so I did it how many times? 3 times, at most 3 times. This is the tree diagram. Did you get it? Do you have any questions? Abdullah, read this one. The arrow on the spinner.
The spinner is spin twice, and the number of when recorded to
But what is the difference between this question and the previous one? Here we are going to draw a probability tree diagram. The previous one we have drawn the tree diagram, but in this case we are going to draw a probability tree diagram. So look at the spinner one. Look at this angle, it's 90. And the loss is 270. So for the first spin, we might get what? Win and lose. We call it not winning. W dash, not winning. So what is the probability of winning? PW equals what? It's 25%, that's right. So it's 1 out of 4, 1 chance out of 4 chances, okay? Because the sector represents a quarter of the circle. And not winning, BW dash, is going to be what? 3 quarters, 3 out of 4, okay? 3 chances out of 4 chances. This is for the first time. For the second time, we have, for the second spin, we have Amr.
another
Win, great, not winning. So we need the probability, so we must write BW equals what? 1 out of 4. And BW dash equals what? 3 quarters. And the next time, we have W and W dash, and we need to write the probability. So BW equals what? BW equals 1 out of 4, and BW dash equals what? 3 out of 4. This is the probability tree diagram. This is the probability tree diagram. Let's go to the next. So if we looked at the previous example for checking the next example, we have dependent and independent events. What are the independent events? If one event is unaffected by the previous event, then the 2 events are said to be independent. Once again, if one event is unaffected by the previous event, then the events are said to be independent. Like this example, if we looked at the previous example. What do you notice? Winning at the second time doesn't depend on the first time, okay? So they are 2 independent events. So what is the definition of the 2 independent events again, Mustafa?
One event is unaffected by the previous event, then the events are said to be
Independent. Like what? The chances or probability of losing on the second spin is unaffected by the first spin. So the 2 events are said to be independent events. Did you get it? What is the meaning of dependent events? The probabilities are affected by what went on before. Again, the probabilities are affected by what went on before. They are depending on each other, okay? Let's read this one. Abdurrahman. A box, okay?
A box contains 3 red sweets.
So a box contains 3 red sweets. We have 3 red sweets. Okay, and
4 blue sweets.
And 4 blue sweets. 4 blue sweets.
the sweets taken from the box.
Okay,
It's color coded and then this.
replaced. Pay attention to this word. Then replaced. What the meaning of replaced?
Yeah, but
What is the meaning of replaced? Okay, let's go on. Another sweet is taken and its color noted. Draw the probability of probability tree diagram. So, Amr, go on.
we have a class of red and blue sweet.
Red and blue. This for the first time. For the second time, you have what?
And another
Red and sweet. And blue, red and blue. Okay. 3 red sweets and 4 blue sweets. How many all sweets? 7. So we have red and we have blue. Okay. So what is the probability of getting red at the first time? 3/7. What is the probability of getting blue? 4/7. That's right. 3/7 and 4/7. Then for the second time, replaced. What's the meaning of replaced?
Get one red, we can get one red and the other.
So for the first time, as you see, for the first time, we can take, as you said, Amr, we have what and what? Red and blue. So red here, BR, okay, and B blue. What is the probability of the first time? The red, 3/7, and for getting blue, 4/7. The next time, because we have then replaced. What the meaning of replaced? We put it again. Okay, so after getting the red, we might get red or blue. So what is the probability of the second time? Probability of getting red, in this case, it will be what? 3/7. And probability of getting blue, B equals 4/7. For the second time, probability of getting blue, we have BR, okay, and we have B. The same. Probability of getting blue, because we replaced it, it will be what? 3/7, and this one 4/7. That's right. Let's go to the next one. Okay, they are independent. Why? Because the probabilities of taking sweets for the second time are unaffected. Unaffected. They are unaffected. Unaffected by what went beforehand. Because we put the sweets back. And if we didn't put the red sweet back in the box, this probability would change. It would change to, as you said, it would change to what? 2 red sweets out of what? Out of 6. Okay. Let's just have a look at this example. Mustafa, read. If you remember, I have explained this example before. We have 6, and if you are going to get 6, so the game will stop. Okay, and if you didn't get 6, so you will go on. You will carry out the experiment again. So here we have B6 and B6 dash. What is the probability of getting 6? It's 1 chance out of what? Out of 6 chances. And to if you didn't get 6, so how many chances? 5/6. This for the first time. And as you know, as you see, here the game stops, ended. That's right. And after getting any number except 6, we will do it again. And we have 2 chances, getting a 6 or not getting a 6. The probability of getting a 6, it's 1/6, and the game will stop. And if you didn't get a 6, you will carry out the game again. So 5/6. Okay, and we will do it again because in the question, at most 3 times. So if you got 6, the game will stop, and if you didn't get 6, it will be 5 chances out of 6 chances. This is the probability tree diagram. What is the meaning of mutually exclusive events? They cannot happen at the same time. They cannot happen at the same time. They are two mutually events. Okay. This one here. A box contains 3 red sweets, 4 blue sweets. A sweet is taken from the box. Its color noted and replaced. Another sweet is taken. Its color is noted. Draw probability. The probability. Draw a probability tree diagram. And we have some questions. Find the probability of getting 2 red sweets, 2 sweets the same color, at least 1 red sweet. So draw the tree diagram, because tree diagram will help us in finding the probability. This is the probability tree diagram. Okay. So the probability of getting a red, BR, equals what? 3/7. And the probability of getting blue, it will be what? 4/7. This is the first time. For the second time, after getting red, we have 2 choices. Okay. The probability of getting red, BR, equals what? 3/7. And P, probability of getting blue, equals what? 4/7. Okay. And if you got blue, then you have 2 choices. For the second time, we might get red or blue again. So PR, in this case, it will be what? 3/7. And P, B equals what? 4/7. That's it. The first question. Find the probability of getting 2 red sweets. P, probability of getting 2 red sweets. So the probability of getting a red sweet, it's 3/7. And the probability of getting a red sweet again, it's 3/7 out of or of the probability of the first one. So what is the probability of getting 2 red sweets? We have 2 probabilities here. We are going to multiply them. Do you know why? I'll tell you. Because we have 3 chances out of 7 chances of getting the red sweet, the first red sweet. For the second one, we have also 3 out of 7 of the first one. To get a red sweet for the second time, it's 3 chances of 7, 3/7 out of or of what? Of the first probability. So in this case, we are going to multiply them. So probability of getting 2 red sweets, BRR or B2R, equals what? 3/7 times 3/7 equals what? 9/49. And the probability of getting red, let's do it. Probability of getting red and then blue. So R, 1 red, and after that blue. It will be what? 3/7 times, so it's PR times BB. It will be what? 3/7 times 4/7 equals 12/49. And this one here, P, probability of getting blue, then red equals what? 4/7 times 3/7 equals what? 12/49. And probability of getting two blue sweets, it's B, 2B, or we call it BB, equals what? 4/7 times 4/7 equals what? 16/49. So what is the probability of getting two red sweets? It will be what? 9/49. Two red sweets. Two sweets the same color. Because I want two sweets of the same color, so we will take the two red plus the two blue, and then you will add them. It will be what? 9/49. So the two red, 9/49 plus 16/49 equals 25/49. At least one red sweet. So at least one red sweet, we will take the two red sweets, and we will take one red and then one blue, and then you will take blue and red, at least one red sweet, and we wouldn't take two blue. So you will add what? You will add, for this one, you will add 9/49, deal with me, plus 12/49, plus again 12/49. Did you get it? This is the solution again. Look at the solution. The probability of getting red, as I did here, probability of getting red and red, it's 9/49. We did it. Okay. And the probability of getting red and blue, 12/49. So the probability of getting to red, it will be what? 9/49. I multiplied red times red. Okay. Abdullah, they are dependent or independent? Dependent or independent? Independent. Okay. Probability of getting the same color, it's a 2 probability of getting two red plus probability of getting two blue, as you see here. Okay. Two red and two blue, it will be 25/49. And probability of getting at least one red, we added probability of getting two red plus probability of getting red and blue plus probability of getting blue then red. Did you get it? Let's move to the next one. Dependent events. The meaning of dependent events, I explained it. Independent event is the probability of one event is affected by the previous event. Affected by the previous event. They are depending on each other. Okay, let's read this one. A bag contains 5 red counters and 2 blue counters. A counter is taken out, its color noted. So we have 5 red, we have 2 blue. And not replaced. Not replaced. So because they are not replaced, so they are dependent events. A second counter is taken and its color noted. Draw a probability tree diagram. Then find the probability of taking 2 different colors. Mustafa, what shall we do? How many counters we have? We have 7 counters. And what are the chances? We have red, BR, and BB. BR equals what? 5/7. And BB equals what? 2/7. This for the first pick. We picked one red, so the probability 5/7. And if we picked the probability of getting blue, 2/7. For the second time, you have what? We have red. You might get red or you might get blue. What is the probability of getting red for the second time?
4 over 6.
Because we took one red from the 5 red counters. So you are left with what? 4 over, don't say 7, 4 over 6. That's right. And if you got one red at the first pick, one red, they are 7, the total 7, the total of them 7. And we took one red. So now we have 6 counters, 4 red and 2 blue. So what is the probability of getting blue in this case? 2 over 6. So we will write it as B equals what? 2 over 6. But there is something very important I want to tell you. There is some students get confused between PR and PR. They are the same. They must be the same. Here 5 over 7 and here 4 over 6. Okay, we couldn't write PR in the second time. So write P R and a line R. What does it mean? That means this is the probability of getting red ball after getting the red ball, red counters at the first time. So it's PRR, not PR. Okay. And the second one, we couldn't write, this is 4 over 6 as we wrote. And the second one is going to be what? It will be BR slash or vertical line, a small vertical line, then B. What does it mean? That tells us we took a red counter and we didn't replace it. And this is the probability of getting a blue counter after getting a red at the first time. It will be what? 2 over 6. Let's go to the next. Abdullah, the second one here. We have red, we have blue. Okay, so BR. We couldn't write BR. We will write what? B, then R. Because we have got one blue, so now, and we didn't replace, so there are 6 counters. So we have 6 counters. And you have how many red in this case? 5 red. And for the last one, B, B, B. It will be what? 1, because we took one blue, so now, and we didn't replace, so now there are 6 counters. And because we took one blue, so you are left with what? 1 out of 6. Did you get it? I want to find the probability of taking 2 different colors. So 2 different colors means red and blue, or blue and red. They are 2 different colors. So raise your hand if you know the answer. Mustafa. Equals what, Mustafa? This one here. Wait a moment. Here. Let's go back. So, what is the probability, Mustafa? Equals what? Of getting 2 different colors. Okay. But this is, we deal with it as BB. Okay. So we have R. We have R. We multiply them. We will multiply 5 over 7 times 4 over 6. So this one, it will be what? 5 over 7 times 4 over 6. This to get what? The probability of getting red, then red. And what is the probability of getting red, then blue? It will be what? Like the previous example, we multiply them. It will be what? 5 over 7 times 2 over 6 equals what? 10 over 42. And here we have blue and red. It will be what? 2 over 7 times 5 over 6. Blue and red. It will be what? 10 out of 42. And probability of getting blue and blue, it will be what? 2 over 7 times 1 over 6. Don't forget it. It will be what? 2 over 42. Because I need to take two different colors. Okay? So it's a tree diagram and we multiply the probabilities. So the two different colors, it will be, they will be 10 over 42 and 10 over 42. Equals what? We will add them. It's going to be what? 20 over 42. Simplify it. 20 over 22, it will be what? 10 over 21. This is the solution here. The probability of getting red and blue, then blue and red, okay? As we did, 10 over 42 plus 10 over 42 equals 20 over 42, okay? Because this probability is dependent. Why? Because they depend on each other. The two outcomes depend on what happened before. Okay, the second outcome depends on what happened before. And we write, don't forget this notation. CP, B, vertical line R. That means the probability of drawing a blue or getting a blue out of the bag, given that I have previously, okay, taken it. I have previously taken it. Okay. So what does it mean? Simply, I took blue, then I find the probability after taking the blue. I hope you enjoyed this session. See you in the coming episodes. Goodbye.